Hi, I'm Jacob, and my group mates are Griffin, Keem, and Nitesh, and we'll be discussing Neo4j. Neo4j is a database manager that incorporates graph theory into its structure. Neo4j constructs directed graphs and can represent data models such as lists, trees, and any number of complex structures. And it is specifically optimized for deeply connected data. Here you can see a simplified example of what an entity relationship model might look like in Neo4j on the right. And you can see a more complex model of what a single node pair relationship might look like. As you can see, each node can have multiple label names and multiple properties, which are attributes, and each relationship can have properties as well. So since Neo4j uses a graph theory for its graph structure, it uses directed graphs, which is defined as a set of vertices and a set of edges. A path on a directed graph is defined as a set of vertices connected by edges. Node vertices can have self loops, so a node can have a relationship with itself. Two nodes are considered to be connected if a path exists between two nodes. And the entire graph is considered to be connected if every node in the graph has a path between the two nodes. The following set operators can also be used in Neo4j when defining patterns. We have union, which is logical or, intersect, which is and, difference, not, and symmetric difference, which is exclusive or. The primary components of the property graph model, which is the data model that Neo4j uses, are nodes, which are entities in the graph. And nodes are defined by labels and can have any number of labels. And they contain properties, which are key value pairs or attributes. Nodes are connected to each other by relationships, which are directed edges along the total graph. And these relationships can construct trees, maps, compound entities, or anything else. Finally, both nodes and relationships can have properties, which are relationships, or which are attributes, And the data types that these attributes can represent are numbers, strings, and booleans. Here we have an example of the detailed property graph. As you can see, it shows several relationships between the different nodes, and each of the nodes have properties. Now I'm going to discuss basic usage in the Cypher query language. So to define a node, we use the following syntax: parentheses with a variable name, and then a colon, and then the label you're specifying. So that's the entity type you're trying to reference. So if you're trying to reference the employee entity type, right here, the label would say employee instead of person. Relationship syntax is simply represented by an arrow. And you can put the relationship type within square brackets inside the arrow to define a specific relationship type. Finally, we have pattern syntax, which is where you have one node with a relationship pointing to a second node. Here I'll show an example using the create, return, and match keywords. Create is used to create new nodes and relationships on a schema. Match is used to query these, query the database and retrieve strings, nodes, and relationships that match the parameters you give. So in this example, as you can see, we're trying to match a person P with the name of Tom Hanks. And once we find that person, we're going to create a new movie with the variable name M, with the title of Cloud Atlas and a release date of 2012. Then finally, we're going to create a relationship between the new node P and the new node M with the type acted in and the parameter, or I'm sorry, property role. And then finally, we're going to return the two new nodes, P and M, and the relationship between them, R. And that return statement will just print a table that contains all of the information. Finally, we have some additional Cypher functionality. We have, in Cypher, you can define indexes on your nodes, which is a starting point for graph traversal. And it's essentially just an ordered list of the nodes based on some parameter. And then there are also constraints. The constraint types that exist in the Cypher query language are unique constraints, which is where no node can have the same property values as any other node with the same label. Then there's also property existence constraints, which pertain to both nodes and relationships. And this ensures that all nodes and relationships with the same label have the same property types as each other. And finally, there's key constraints, which states that all properties must exist on all nodes with the same label, and the combination of property values must be unique. And then finally here we have a table that shows naming conventions for Cypher. Basically, they prefer camel case and uppercase. We also have merge, the merge function, which if we define a pattern on an arbitrary set of nodes, we can extend that pattern across the entire tree, such that if we define a general case, we can add new connections based on the parameters that we give. And then we also have the where function, which is used to filter data. So in the example here, we say match, which is essentially select D from department. So I want one department D from the department table, where the specific D number is equal to 5, and then I'm going to return all of the departments with D number 5. And then Cypher also has aggregate functions, and the aggregate functions supported are count, sum, average, min, max, and collect. And all the collect function does is select the parameter you're given and compile that into a list. And then here we have an example of a basic query, which shows us creating the person named Anne and another person named Dan, and creating the relationship loves between the two. Then we can run a match on the person Anne to see who she loves and return that person.
Hello everyone, my name is Kim, and I will continue the presentation by discuss about the Neo4j use cases and industrial adaptation. Let's get started. So as we already discussed, Neo4j is a graph database. So the question is, compare with relational database like MySQL, what is the advantage of Neo4j? And the answer is, it is optimized for deeply connected data. Neo4j will emphasize the relationship between data points rather than quantity of data. For example, as we already learned in database class, the MySQL will create a table for each entity, right? And each table will have the specific relationship to another table. But in Neo4j, each data point or each row in the table of MySQL will have a different relationship to another data point. So it will emphasize the relationship rather than listing row by row of data. I will show you the difference later. So for the use cases in industry, first talking about AI and natural language processing, or NLP. AI will study about neural network. You know, a neural network will have each neuron connected to many different neurons, and each neuron will have a specific relationship with different neuron because of the weight. So a study, it will very helpful in AI research. And also for NLP, for it will study the relationship between words in the language for the purpose of translating a virtual assistant. For example, like um, for recommendation, a word in a sentence. Example, we have a sentence like, I am a student. I go to dot 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 every day. If we compare between graph database and the table database, we will understand that the dot 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 will most likely is good because it connect to different different data point in that sentence, different word in that sentence. And secondly, we have fraud detection and analytics. It is a study about relationship of online activities and behavior to detect scam pattern on the internet. Thirdly, we have supply chain. Manage and optimize the flow of goods. It's very important for recommend recommendation system for retailer. Um, Social network and social media. And obviously, we know that social network is already a graph, so there's no point to convert it into a table database because it's, um, because in social network, each person is connected to different person by a relationship. So we can apply the database like Neo4j to optimize the connection inside, or to do or to use it to do whatever we want. Product recommendation engine and system. Again, it is very important for retailer, for a big retailer. It will study customer behavior and recommend product in real time. Next, industrial adaptation. This this statement right here is copied from the Neo4j webpage. Today, thousands of organizations, from startup to Fortune 500 companies, are using Neo4j to build new and innovative applications that leverage connections in data, such as recommendations, impact analysis for network and IT operations, real-time routing for logistics, and the next generation business applications, such as master data management, identity and access management, content management, fraud detection, portfolio, and risk management. So you can say in this complicated world where relationship matter, the relationships between entities are become are becoming very important. The graph database is more and more important, not like traditional table database where we just list everything. So um, in the image right here, we can see some of the big company make the use of Neo4j, like Adobe, Walmart, Microsoft, Cisco, um, eBay. Yeah, and that's it for this part.
Hey, my name is Nitesh, and today we're going to talk about the features, advantages, and limitations of Neo4j. So, as we know, Neo4j is a database used to model the data in the form of a graph. So, what we should notice is that in here, the nodes of a graph depict the entities, while the relationships depict the association of these nodes. Um, Nowadays, most of the data exists in the form of a relationship between different objects, and more often, the relationship between the data is more valuable than the data itself. Um, relation Relational databases store highly structured data, which is why we have several records of, storing the same data. I mean, the same type of data, so that they can be used to store structured data, and they do not actually store the relationships between the nodes. Between the data, and compared to graph databases. Compared to relational databases, graph databases store relationships and connections as first-class entities, which means that the relationships and connections are given the utmost priority. Um, and the data model for graph databases is simpler compared to other databases, and they can um, be used with OLTP systems. They provide features like transactional integrity and operational availability. And now let's talk about the features. So we have several features right here: Cipher, asset properties, scalability, reliability, data model, and drivers and indexing. So first, Cipher. So Neo4j provides a powerful declarative query language known as Cipher. It uses ASCII art for depicting graphs, and Cipher is very easy to learn and can be used to create and retrieve relations between data without using the complex queries like joins. And talking about the asset properties, ACID stands for atomicity, consistency, isolation, and durability. And one of the features of Neo4j is that it supports full ACID roles. It supports atomicity. It supports every single one of them. And then going on about scalability and reliability, they go hand in hand most of the time. And you can scale the database by increasing the number of reads or writes, and the volume without affecting the query processing speed, data, and integrity. Um, Speed of the data and its integrity. And also, Neo4j provides support for replication. This is not found in, this is pretty rare to be found. And this replication is used for data safety and reliability. And now moving on, we should talk about the data model that Neo4j follows. So Neo4j follows a data model named native property graph model. So here, the graph contains nodes or entities, and these nodes are connected with each other, which are depicted by relationships. And nodes and relationships store data in key value pairs, and these key value pairs are known as properties. In Neo4j, there is no need to follow a fixed schema. There's no rule that you should follow a specific order or a pattern. You can add or remove properties as per requirement, and it also provides schema constraints. Now, talking about drivers. So there are specific several drivers with which the Neo4j can work with. So it can work with REST API, which is used to which is used to work with programming languages such as Spring or Scala, etc. And we also have JavaScript to work with UI MVC frameworks such as Node JavaScript, Node.js, which is Node JavaScript. And it also supports two kinds of Java API, Cypher API and native Java API to develop Java applications, obviously. In addition to these, you can also work with other databases such as MongoDB or Cassandra, etc. And moving on, we should talk about indexing. Indexing is not that big of an important concept, but it's a simple concept. So indexing, there's nothing important about it. Neo4j supports indexing, and it does this by using Apache license. Now, let's talk about the advantages. So first, we have a few advantages: flexible data model, and then availability, retrieval, real-time insights, and joins. So first, flexible data model. So Neo4j provides a flexible, simple, and yet powerful data model, which can be easily changed according to the applications and industries and requirements. And just like before, we don't need to follow a specific norm. And high availability. So Neo4j is known for becoming highly available for large enterprise real-time applications and transactional guarantees. And moving on, we should talk about retrieval. So using Neo4j, you can not only represent, but also easily retrieve. Retrieve in the sense you can traverse or navigate through the connected data faster when compared to other databases. And real-time insights. So this is just like indexing. This is not that big of a concept. So Neo4j provides results based on real-time data, and this is what it means. And joins. So just like we talked about it before, there are no joins. And using Neo4j, it does not require complex joins to retrieve connected or related data, as it is very easy to retrieve its adjacent node or relationship details without joins or indexes. And now we should talk about the disadvantages, which are the limitations. All right. Compared to the advantages, there are not that many limitations. So this does indicate that Neo4j is very good to use, and it is the better software to use. We only have three limitations here: data residing, range search, and master-slave architecture. The last one is pretty important. So data residing. So the thing is, whenever we install Neo4j and whenever we work with Neo4j on a machine, you need that data in memory if you want to avoid expensive disk seeks. If you want to work with some data on a computer with Neo4j, it should be available. You don't want to first thing waste time and the thing is, once your data sets become larger than the available RAM, the systems will dramatically slow down. It's just like a normal computer. I mean, if you have many and many files and files, it's going to become hard for the computer to search for a specific file. And this is going to be uh, um, a disadvantage because it's going to take much time, and it also uses much RAM, and this results in usage of much power. Um, and so just like that, if your data set is larger than the random access memory, then it is practically, I mean, I wouldn't say impossible, but it is possible, but it's going to be slow. And no sophisticated index mechanisms are supported. So this is called range searching. So this means that searching for ranges through Neo4j is practically impossible. It cannot be done. And now the important one, master-slave architecture. Um, so whenever we use Neo4j, writes are always done on the master. Because it works, because it has the master slave architecture. I mean, if you try to write something on a slave, then the write will be forwarded directly to the master internally. And good thing is that, once a master goes down, it doesn't take long until a new master is elected. And the thing is, when a master goes down and you try to write something, there is a very good chance that between the time you wrote something and the master was down, um, your your Neo4j has already come up with a new master. That's what it means. So um, today we talked about features, Cipher as a properties. Sorry about the sounds. Cipher as a property, scalability and reliability, data model, and drivers indexing. And advantages, it has a flexible data model, and then it's readily available, and its retrieval of data is incredible, real-time insights, and no joins. And limitations. Obviously, data residing, we cannot use a machine that does not store the data. We have to have the data at all the time, which slows down because of excessive usage of RAM or greater than a memory of RAM. And then range search, it is practically impossible. You cannot do it. You try to do it, you can, because it's impossible. And master slave architecture, you try to write data on a slave, it's not possible. It gets directly transferred or directly written on the master internally. But the good thing is that, whenever a master goes down, there's going to be a new master readily elected.
Hello again. In this part, I will compare between Neo4j and MySQL because we already study MySQL on class. So what is the similarity and difference between Neo4j and MySQL? In Neo4j, it's a graph database, and in MySQL, it is a relational database. Both Neo4j and MySQL are open source. Neo4j is described as the world's leading graph database, while MySQL is described as the world's most popular open source database. Here comes the difference. The Neo4j store data in nodes, and the store data in node, and the nodes are connected to another node by directed type relationship with property on both sides, also known as property graph. And in MySQL, we store data in set, and the set belong to a table or a relation. The set is basically a row of data in a table, like we already studied. This is a major difference between those two. In Neo4j, the relationship is on individual level, and in MySQL, the relationship is in higher level or the table level. What I mean by that is you can imagine the table in MySQL and you have different row. Each row is the data point, and in MySQL, the relationship in MySQL is the relationship between table to table, from relation to relation. But in Neo4j, each row in the table have relationship with another row on the same, can have different relationship with another row on the same table. So it very emphasize significantly on relationship between data points. So we can say Neo4j is optimized for deeply connected relationship, and in MySQL, it's faster when operating on a huge number of records because it keeps listing and listing. It doesn't need to keep track of the relationship between data point. So we can say that in Neo4j, it requires more storage when storing the same amount of information in MySQL, because MySQL doesn't need to store the relationship between data point to data point. So when to use Neo4j and MySQL? We use Neo4j when there is a big variation in relationship between each data point. For example, in the family tree, where each member in the family is connected to another member of the family, which are different relationship. And in MySQL, it will be used when data is categorized into small number of entities. So the number of relationship is limited. For classic example right here, a database of department, student, and faculty. The relationship between department to student is pretty limited, like just one or two. The relationship between database and faculty are the same, like the chair in the example, on the class example.
All right. I am going to do the tutorial and installation guide for you guys. At this point, you have hopefully gained a pretty good grasp about graph databases and the Cypher language when using Neo4j. And now to begin, let's go to the Neo4j website right here. And so just go to neo4j.com, and we're going to start by clicking Get Started. And then go ahead and download the Neo4j desktop. Click Download. And go ahead and put all of your information right here. I went ahead and put my tcu.edu email address. And go ahead and just click Download Desktop. And it should begin downloading pretty soon. And I may fast forward through this part because it takes a few minutes sometimes. Okay, so it's all downloaded, and now we are going to go and click that. And this may be different depending on your operating system. but I am using a Mac. And so this window should pop up, and all you need to do is drag it over to your applications folder. And it's copying it. There you go. And you can just go to open up a new Finder window, and we're going to go to Applications, and Neo4j Desktop. And eventually this window will pop up, and go ahead and you can read this if you want, and go ahead and click I agree. And you can decide to register. When I did this, I just decided to click register later. It goes through this process of installation. And this is an example database that we're going to recreate. So I'm going to go ahead and remove that because we're going to start from scratch. So they actually give you this Neo4j primer project. So it's a database that is already built in just to help you kind of understand how to use this application. So we're going to go ahead and start that just to give you a little bit of introduction. So yeah, click start, and then in a moment after it's done starting, you can open it on a local server. And as you can see already, this is a pretty big database. It has 172 nodes and 251 relationships. And as you've learned, these are direct relationships because Neo4j really focuses on the relationships as well as the individual nodes. So go ahead and click open with Neo4j browser. That'll pop up this window. And you can go ahead and click this little database icon, and it will actually give you some more information on your database. In this case, we have these different nodes. We have message, movie, person, relationships. We have things like follows, directed, and again, this is a movie database, so you can kind of think of it in that context. And actually, it gives you some example queries. You click example graphs, and we're using the movie graph. You can, there you go. So gives you some example queries here. For example, let's say you want to find the actor named Tom Hanks. So as you've learned, you want to do a match statement. So match, and we're going to call this variable Tom, who has the attribute name is Tom Hanks, and then we're going to want to return that node. So go ahead and click that. And this is what's really cool. The Neo4j desktop browser actually gives you a graphical representation, table representation, then text. And you click it, and you can see the different attributes associated with this node. And you can close this window and check out maybe some of the other ones. This one's a little bit more involved. Here we're finding the movies released in the 1990s. So again, let's open this up. So match, and we're going to call this 90s, and it's a node type movie where 90s, the property released, is greater than or equal to 90, and that property is less than 2000, because we're only trying to find the movies that were released within that decade of the 90s. And then we're going to return the title property for all those nodes that satisfy this condition. So let's go ahead and return that. And in this case, we just get this table representation, the matrix, When Harry Met Sally. But yeah, that kind of gives you a little bit of an idea of how this application works. So let's go back here. We're actually going to close out of this window, and we're going to stop. And in your case, you're going to want to go up here and click New, and it's going to bring up a new project. You can call it whatever you like. Let's call this project Intro to Neo4j. And let's create a new database. So we're going to create a local database, and we're going to do a very familiar example. Let's call this University. And you have to set a password. You can do anything you want. I'm just going to say password. And we're going to go ahead and create that. So we're actually going to see how we can kind of translate some of the work we've done with MySQL. So we're going to start this. Okay, so our university is now active. So our next step is to go ahead and click Open. And again, it's going to open up a new window on a local host. And again, you can click this little icon. You can see more information on your database. And in this case, we just created a brand new database. So we aren't going to have any nodes. We're not going to have any relationships or any properties. So, we can do something really simple, like we learned before. Let's say we want to create a node type faculty, and let's give it the attribute name to be Joe. And go ahead and run that. And you can see one label, one node with one property set has been completed. You go ahead and click that new node type, and we can see faculty is right here with the name Joe. So we can do it this way, but it's kind of tedious to create each individual node. So I'm actually going to go through the process of loading a CSV file. So let's go ahead and delete that guy. Cool. So that just matches any nodes and deletes them. So now we're starting from scratch, and let's go ahead and work with a couple of really simple data, some really simple data, but we're going to load it from a CSV file. So I'll go ahead and show you the CSV files. This is our department. So in this case, we have two columns, department ID and the department name. We just have computer science, math, engineering, and biology. And then our other one is just a load faculty CSV file. So in this case, we just have the faculty, social security number, the name, and what department they work for. So we're going to show that relationship in this example. So let's get started. The first thing you want to do actually is, in order for Neo4j to be able to import a CSV file, you need to go to wherever Neo4j is located within your file system, and that's going to change depending on your operating system. In my case, let's go here. So once you have that pulled up, you're going to want to try to find the subdirectory called import. So putting those files into your import subdirectory will allow Neo4j to recognize those files and enable Neo4j to load those CSV files from your local machine. So go ahead and if you want to create those CSV files, you can go back in the video and then go ahead and plop them into this import folder. Okay, once you have these CSV files in your import subdirectory, we can go ahead and move on. So, first thing is we are going to want to start with this load statement. It's pretty simple, very similar to what we've done in the past. So you're going to want to do load CSV with headers, because we provided the headers for the column names, with headers from. And now here you want to provide your file path. Again, this actually should not be specific to your machine, because since we put those CSV files into the import folder, we're able to provide this specific path name. So go ahead and put file, and then colon, and then it's just 3 forward slashes, and then our first file that we're going to import is the department CSV file. So load department.csv, and we're going to say as row, and this is just an alias. You can call it anything you'd like. It's basically so that we can reference the data once we load it. So we're going to say as row, and oh, that's not done. As row, and yeah, we're not done yet. And then we're going to say create. And now we're going to create all of our nodes for department. So now that we have the CSV data, we can say row, as row create. We're going to call this variable d of type department. And now we're going to pass in some different properties. So the first one that we saw in the CSV file was department ID. And the way we get that data is we just reference that row variable that we already defined, and row.department ID from the CSV file. And we have one more property, which is department name. And department name, we just get that again from that row variable from the CSV file. Again, it's just called department name. And there you go. That should work. Let's see what happens. There you go. So we just added 4 labels, created 4 nodes, and set 8 properties. We can actually go back over here. We can see the 4 departments that we just loaded from the CSV file. So it's looking good. The next step is, well, first of all, those department IDs, we're going to be using that to reference former faculty nodes, and whenever we make those relationships. So kind of similar how we do in MySQL, we can set certain properties to be unique. So let's go ahead and do that. And again, this is called, just like in MySQL, it's a constraint. So let's go ahead and create a constraint on all the nodes of type department. We're going to say assert the department ID to be unique. There you go. So we just added 1 constraint, and now we can move forward in loading the faculty nodes. So very similar to before, we're going to say load CSV with headers from And we're going to do a very similar path. So file, colon, 3 forward slashes. We're going to say load dash faculty.csv. And again, we can name this whatever we want. Let's say row. And now we want to create all of our faculty nodes. So create, let's call this F, and it's going to be of type faculty in this case. And again, we're going to have some properties. So the first one, as we saw before, was the faculty social security number. And we're going to get that from referencing row, faculty social security number. And then the next was our faculty name. So we call that name. And we're going to reference that from row dot name. And then we have one more, which is called works for, which is from row dot works for. And there you go. That should be it. All of the data from that CSV file should be loaded to create all of our faculty nodes. And it worked. So we have 6 labels, 6 nodes, and set 18 properties because we have 3 properties for each node. And we can actually see, let's go ahead and if you click this down, you can see all of our nodes. So these are all of our departments, all of our faculty members, but there are no relationships. And this is the really important part. So now we want to create relationships between faculty members and departments. And in this case, every faculty member is going to be working for the department. So let's go ahead and work on creating that relationship. So as you have seen before, we can use our match statement. So we're going to be wanting to match faculty members with departments. So let's match faculty. And this is very similar to cross product that we have done in MySQL. So we're going to match nodes of type faculty with nodes of type department. And very similar to what we've seen, we're going to use where to select specific nodes that we've already imported. So we're going to say where the faculty's works for is equal to the department ID. Just like what we've seen before, the foreign key equals primary key. Very similar. Now we're going to want to create a relationship between faculty member and department. And I'm not going to go too much into the syntax of Cypher here. Hopefully you got a good understanding from previous in the presentation. But this is the syntax. You just do dash. And it's very similar to what you'd expect. So let's call this works for. So faculty works for, put a little arrow, which is just, again, it's just a dash and a greater than sign. And then we're going to do nodes of type department, and we can call that D. And yeah, there you go. So again, to kind of recap on that. So we're matching faculty nodes with department nodes, and on the condition that the works for on the faculty is equal to the department ID from the department node. And then once we find those matches, we're actually going to create a new relationship between the matching node with the department, and the node is faculty member works for department. Oh, and actually, my mistake. We just need to put the variable names, F and D, that we set where we go. And so we'll go ahead and run that. Oh. We just put capital instead of lowercase. All right, let's run that again. All right, perfect. Created 6 relationships. And now we can go ahead and click our relationship types. And there you go. So we can see our relationships here. we know that Kathy works for the math department. James works for the biology department. In this case, Jan and Peter both work for the engineering department. And same for computer science for Joe and John. So it's pretty cool. What I really like about Neo4j is seeing this graphical representation of of the data that we're putting into the database. And now we can do some other queries. Let's say, for example, we want to find all the faculty members that work for Department 3, which in our case, Department 3 is the engineering department. So let's just say match all faculty members, so nodes of type faculty that there's also really good IntelliSense that work for, again, nodes type department, but we're going to set property here. So we're going to say department ID is 3. And make sure to put the single quotes whenever you're querying. And then at the end, so after we find those matches, those nodes that work for departments, that work for Department 3, we're going to return those faculty nodes. So just say return F, which is the name that we set here. And there you go. As we saw before, Peter and Jan work for engineering department, and we return Peter and Jan because they work for department with department ID 3. So that's all I have for the installation and tutorial. This is just a very basic layout. In the homework, you should get more practice working with the Cypher language and understanding graph databases. I hope this was helpful for you guys. Hopefully this can get you started and kind of give you a good understanding of why graph databases are important. And I hope you enjoy the homework assignment, and I hope you learned something new. Thank you.